Okay, in this video I'm going to continue on with exercise 6a of the book Fundamental Applied Mathematics. We're on page number 156 and the question is 7. It reads: a car whose weight is 5,000 newtons climbs a hill of incline 1 in 20 at a steady speed of 12 meters per second. If the resistance to motion is 500 newtons, find the power output of the car's engine. So as you can see, I've drawn the free body diagram and I've put in only the information at which we're well able to do at this stage. So in green I have the velocity vector, the normal vector and the frictional force. Notice of course we're given the friction in terms of newtons, so that means this is the frictional force, okay? We don't have to work out anything else. The car must be driving, so it must have a force pulling it up the hill, which I'm going to call D. By the way, notice as well my unit vectors which don't change for inclined planes. The weight vector is 5,000 newtons. Notice that's already a force, therefore you don't need to incorporate gravity. It's already incorporated. So I just resolve that into minus w sub y j hat and minus w sub x I hat. I'll let you do that yourself. The angle we're given as inverse sine 1 over 20. If it's an angle of 1 in 20, that's what it means there. Next we know that the power is equal to the force vector times the velocity vector, and the sum of the forces is equal to mass times the acceleration. Now, if we analyse Newton's second law, which we're well able to do at this stage, we know the following things. If the acceleration is equal to 0, then the sum of the forces must be equal to 0. Alright? And if the acceleration is non-zero, then the sum of the forces is non-zero. So there is a net overall force if and only if there is an acceleration. And if there is no acceleration, there is no net overall force. And that's very important because we need to now analyse the information we're given. We're told that it's moving at v is equal to 12 meters per second. Okay? That means the velocity is equal to a constant. If the velocity is constant, that means the acceleration is 0. Do you remember, of course, acceleration is the rate of change of velocity with respect to time. So if your velocity isn't changing, well then your acceleration is 0. So it could be like v minus v over t, that sort of thing, and it's going to be 0 over t, which is equal to 0. That sort of thing. I know it's done by differentials, but anyway. So that means that we have no acceleration. That means the sum of the force vectors affecting the car, or not the car, it is a car, isn't it? The car are equal to 0. Alright? Because the car is the thing moving at a constant speed. So let's look at the I hat unit vector direction. We're going to get that d I hat minus 500 I hat minus 250 I hat is equal to 0. Notice we weren't even given the mass because we didn't need it. So that means d, of course, the d vector d I hat is equal to 750 in the positive I hat direction. So that is the force. That is the force driving the car. So just let's read the question again. It says the car's weight is 5,000 newtons. It climbs a hill of incline 1 in 20 at a steady speed. If the resistance to motion is 500, find the power output of the car's engine. Now you need to be smart here. And I'll tell you why. Because we're being asked to find the power output of the car's engine. So we're being asked to find out the power associated with this vector. We're not being asked to find out the overall power. In other words, we're not being asked to have d minus 500 minus 250. Now I know that's going to be 0 anyway, but the point is that we're just interested in what the engine is able to do. So we just use the force of the engine. So for that reason, this power is equal to force times velocity becomes power is equal to d times velocity. So we're going to get 750 times 12 is equal to the power vector, or the magnitude of the power. So let's see what that is, and we get an answer of 9,000, and the unit of power is watts. Alright, so thanks for watching. Please pass it on to your friends and subscribe to my channel.